These lizards are leaping for science. Well, not so much leaping as falling. But their tumbles are helping scientists answer a question. Could hurricanes drive natural selection? Hurricanes are destructive, perhaps too destructive to influence evolution, with species survival being more random than influenced by specific traits. And while some scientists suspect that hurricanes could drive natural selection, this has never been documented. That is, until a group of researchers happened to be measuring anole lizards in the Caribbean. They surveyed lizards on 2 small islands in Turks and Caicos just days before Hurricanes Irma and Maria struck. Winds reached speeds of more than 200 kilometers per hour, felling trees and flattening vegetation. But after the devastation, the scientists had a rare opportunity to see how the hurricanes affected the lizard populations. They went back and measured the lizards left on the islands. On average, those that survived had larger toe pads and shorter femurs. The males also had smaller bodies. Researchers suspect that these small differences might help the animals cope with high winds. But how? Well, that brings us back to lizards falling into nets. This simple test, done with a leaf blower, demonstrates how they respond to high wind. To stay on the branch, the lizards tuck their forelegs under their body and out of the wind. But their hind legs stick out, catching the wind until they ultimately lose their grip. The scientists say that shorter femurs and smaller bodies could help them hang on. Additionally, the lizard's toe pads are covered in tiny ridges. Larger pads means more ridges and so better grip. Right now, this is mostly speculation, but it could explain the differences the researchers measured after the hurricanes. And that raises the possibility that hurricanes could act as a selection pressure, favoring lizards with wind-resistant traits. And if the traits stay in the population, that could drive evolution. Picking apart processes like this will help conservationists predict how ecosystems adapt to extreme weather events, which we'll see more of as the climate warms. But for now, let's appreciate these little anoles for their contribution to evolutionary science.